Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Amir Haikal bin Abdul Rashid. My number is AA240947. I am from Group 3 and we are going to be presenting a simultaneous nitrogen and phosphorus removal process.
So I'm going to review about the tertiary treatment. We know that even though the water already suppressed the secondary treatment, but we must take note about the secondary treatment limits. We know that secondary treatment efficiently removes above 85% of BOD and suspended solid, but provides minimal reduction of nitrogen and phosphorus compounds. So for the tertiary treatment process, advanced stage includes filtration, carbon adsorption, chemical phosphorus removal, and biological nitrogen removal for higher effluent quality. Why is it matter? It is matter because excess nitrogen and phosphorus cause eutrophication and toxicity. Tertiary treatment is essential for environmental protection and water use.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Nurqudratullahi Masiri. My matrix number is AA251571. So next, I will explain the fundamentals of nitrogen removal. Nitrogen in wastewater exists in several forms, which are ammonia or NH3, ammonium or NH4+, nitrate or NO2-, and nitrate or NO3-. Each of these forms behave differently in aquatic environment and affect water quality in different ways. Among these, ammonium, which is NH4+, creates a high oxygen demand during a nitrification process. This means more dissolved oxygen is consumed during treatment. At the same time, free ammonia, or NH3, is toxic to fish and other aquatic organisms, even at low concentration. Besides that, excessive nitrogen in water bodies can stimulate rapid algae growth, also known as algal bloom. This condition reduces dissolved oxygen in water and may lead to eutrophication, which can harm aquatic ecosystem. To remove nitrogen, these are two main methods. The first is biological removal through nitrification and denitrification, where nitrogen compounds are eventually converted into nitrogen gas and released into the atmosphere. The second method is chemical removal, known as ammonia stripping, where the pH is increased to convert ammonium into ammonia gas so it can be removed.
So next, I'm going to present about a nitrification process. There are 4 steps in this process. For the first step is ammonia to nitrate. NH4 plus with 1.5O2 is equals to NO2 minus plus H2O plus 2H plus is catalyzed by nitrosaminase bacteria. For the second step, which is nitrite to nitrate, NO2 minus plus 0.5O2 equals to NO3 minus catalyzed by nitrobacter. Overall, NH4 plus with 2O2 equals to NO3 minus plus H2O plus 2H plus. For the third step is aerobic conditions. It requires DO more or equals to 1.0 milligram per liter with optimum pH is 7.5 to 8.5. The maximum rate at temperature is 30 to 35 degrees Celsius. The last step is inhibiting factors. Toxic compounds inhibit nitrification. Low dissolved oxygen, extreme pH, and heavy metals reduce bacterial activity. So I am also going to present about denitrification process. First, the equation 6NO3 minus plus with 5CH3OH is equals to 3N2 plus 5CO2 plus 7H2O plus 6OH minus. Nitrate is reduced to nitrogen gas using methanol as carbon source. For the second is key condition. An oxy environment required dissolved oxygen less than 0.5 mg per liter. An external carbon source is essential for the reaction. Third one is bacteria involved. Facultative heterotrophic bacteria such as Pseudomonas drive the process under anoxic conditions. The last one is process requirement. Denitrification must be preceded by nitrification. less sensitive to toxic compounds than nitrification.
Hi, Assalamualaikum. My name is Muhammad Kashali bin Jumadi. My metric number is AA250709. So now I will explain phosphorus removal treatment processes. Phosphorus removal is important because too much phosphorus in water can cause algal blooms and reduce oxygen levels, which can harm aquatic life. The first method is ferric chloride treatment. Ferric chloride reacts with phosphate to form a solid precipitate that can be removed from wastewater. This method works well at a pH of 5.5 to 7. The second method is alum treatment. Alum also reacts with phosphate and forms a solid that can be separated from water. It is commonly used in tertiary treatment systems. The third method is lime precipitation. Lime reacts with phosphate to form sludge, which can then be removed. This method works better at higher pH. Besides chemical treatment, phosphorus can also be removed using integrated systems such as FIFAS, SBR, MBBR, and MBR. These systems can remove both nitrogen and phosphorus at the same time, making the treatment process more efficient. So now I will compare nitrification and denitrification. Nitrification is the process where ammonia is converted into nitrate by autotrophic bacteria such as Nitrosomonas and Nitrobacter. This process happens under aerobic conditions, meaning oxygen is required. The dissolved oxygen should be at least 1 milligrams per liter. Nitrification has a slow growth rate and works best at a pH of 6.5 to 8.5 and a temperature of 16 to 35 degrees Celsius. In contrast, denitrification is the process where nitrate is converted into nitrogen gas by heterotrophic bacteria such as Pseudomonas and Cyprinium. This process occurs under anoxic conditions, meaning very little oxygen is present. The dissolved oxygen should be below 0.5 mg per liter. Denitrification has a faster growth rate and performs best at a pH of 7 to 8.5 and a temperature of 26 to 38 degrees Celsius. In conclusion, both nitrification and denitrification are important for nitrogen removal. Together with phosphorus removal, they help improve wastewater treatment efficiency.